Today we're going to be looking at trigonometric functions, and in particular the unit circle. Now I know the unit circle is nobody's favorite math concept, but it's actually very useful. So let's go looking at it. First off, we're going to define the 6 trigonometric functions. We should be familiar with them: sine, cosine, secant, cosecant, and then we have tangent and cotangent. Then we're actually going to look at some of the graphs associated with this, okay? Identify them as even or odd, and then we're also going to look at the period property. Remember, as we go around a circle, the degrees start to repeat. And so trigonometric functions have a period, or basically a point at which they just start repeating, and we don't really need to think of the graph other than the part that doesn't repeat. Okay, and then we're going to recognize and apply fundamental identities associated with our trigonometric functions. Okay, so first off, what is the unit circle? Okay, the unit circle is simply a circle whose radius is exactly 1 unit. Okay, and the reason we make it 1 unit is because it makes a lot of the math a lot simpler. Okay, so when I look at something, a point on that circle, okay, so right now I've moved the arrow and now I'm pointing at a different point on the circle. This point has an X location and a Y location, but I know it's 1 unit, exactly 1 unit away from the origin. Okay, and so if I look at that angle, that radius is 1. Okay, the X and Y coordinates are there, and those X and Y coordinates can then form a right triangle. Okay, how much in the X direction, how much in the Y direction. And looking at this triangle, okay, all of the trigonometric functions are pretty much based off of this triangle. If I was to increase the radius, okay, or change the radius to some other number, I can simply multiply all the sines, cosines, tangents, whatever, by that radius to get the new value with a different radius. Okay, so for instance, the X position, okay, that's basically the cosine of that angle theta. The Y position is the sine of that angle theta. Okay, this is some aspects that I talked about back in physics last year. Okay, so yes, it's labeled X and Y, but it could just as easily be labeled cosine theta, sine theta. Okay, the tangent theta, okay, comes because if I draw a tangent line that's perpendicular, if I draw a tangent line that's perpendicular to the circle at that point, okay, then the length of that line is effectively my tangent theta. But personally, I like to think of tangent theta as the slope of that radius line, okay? The slope of that green line, that's what the tangent theta happens to be. Okay, so let's take a look at the 6 trigonometric functions, okay? We have sine, cosine, tangent. Those are the base functions, or what I consider the base functions. All the other functions, cosecant, secant, and cotangent, are effectively inverses of those 3's, okay? Cosecant is this inverse, or 1 over sine. Secant is 1 over cosine, okay? Cotangent is 1 over tangent, okay? So if I look at it in terms of x, y values, okay, really, I just want you to memorize the left side, okay? Sine theta is the y value. Cosine theta is the x value. Tangent theta is y over x, or like I said, the slope of that line, rise over run. Okay, the other 3, it's almost better to just think of them as 1 over sine, 1 over cosine, or 1 over tangent. Okay, but some of these will be the fractional values, okay, cosecant, secant, cotangent, and tangent. Anything with a fraction will become undefined, or again, it'll become asymptotic, okay, when the denominator approaches, or denominator is 0. Okay, so here I have an example. Okay, use this figure to find values of the trigonometric functions. I have an x value and a y value given. Okay, square root of 3 over 2 and 1/2. Okay, the formula in the corner there, x squared plus y squared is equals 1, is the formula for a circle. Note that a circle is not a function. Okay, it fails the vertical line test. There's also no inverse because it fails the horizontal line test. Okay, but we can, sine t and sines and cosines and tangents, those are different aspects. Okay, see if you can fill out this table given that point on the circle. okay? Just look at the x values and the y values. If you need to go back to the previous slide, go ahead and do that, okay? So, looking at this, the y value and the x value are sine and cosine. I can get the tangent by doing sine divided by cosine, or y divided by x. Okay, getting to the sine, the other side, I'm really just taking those inverses, 1 over 1/2, 1 over square root of 3 over 2. Okay, the inverse of tangent t, I actually just flipped the two fractions instead of 1 divided by. So those are the values for all 6 of the trigonometric functions if I have a point on the unit circle. Okay. So, domain and range. Looking at the range and looking at the unit circle, okay, the range of the sine and cosine function is -1 and +1. It can't be any larger than that, okay? They can be anywhere between -1 and +1. Brackets, okay, because -1 and +1 are the possible values. So sometimes we'll talk about the maximum possible value for the sine and cosine being +1, and the minimum possible value being -1. Okay, the domain, however, the domain of the sine and cosine function is all real numbers because I can go around and around that circle as much as I want and end up with something I can take a sine or a cosine of. Okay, so let's look at the trigonometric functions and the graph of them. Okay, here I have sine, cosine, and tangent. I'll talk about the other three on the next slide, okay? But looking at these slides, okay, it's going to be important to realize which of these are even. Basically, which of them will the sine of x equal minus sine of x, and which ones are odd, okay? Sorry, not minus sine, okay? F of x equals f of minus x would mean it's even. F of x equals minus f of minus x would mean it's odd, okay? And if these are even or odd, would their inverses or their co-functions, the cosecant, secant, cotangent, would those also be even or odd? Okay, so let's take a look at them. Here's our 6 functions, okay, and decide for yourselves which ones are even, which ones are odd. Okay, the cosine function is clearly even, okay? It's the same thing on both sides of the x-axis, y-axis, okay? And if the cosine is even, its inverse, or the secant function, will also be even, because I've not done anything to change cosine of x equals cosine of minus x. It would be the same thing. 1 over cosine of x would equal 1 over cosine of minus x. Okay, the other sides are both odd functions. Okay, the tangent and sine are both odd, and their inverse functions, cotangent and cosecant, are also going to be odd. They are mirror reflected over the origin, or f of x equals minus f of minus x. Okay, so those are our even and odd functions, and we can use that to simplify our ability or our need to calculate values. Okay, so let's look at the values. Okay, I will also have asymptotes. If I look at the 3 functions on the bottom and the tangent function, there's going to be asymptotes associated with these. Okay, and so vertical asymptotes exist whenever the denominator would equal 0. So tangent, cosecant, secant, and cotangent all have situations where the denominator would equal 0. For the tangent theta, it's when your cosine of theta equals 0, basically at 90 degrees and at 270 degrees. Okay, cosecant, different points, secant, and cotangent. Okay, so we can go back to the pictures and figure out where they have asymptotes based on when the sine and cosine are going to equal 0. Okay, so our fundamental identities. We have the reciprocal identities. We've already talked about the fact that sine theta and cosecant theta are inverses of each other. Cosine and secant are inverses of each other. Tangent theta and cotangent theta are inverses of each other. Okay, then we have the 2 quotient identities. And the fact that the tangent theta equals sine theta divided by cosine theta, I think that one's important because there's a lot of times that we're going to need to convert tangent theta to sine theta and cosine theta just so we can simplify our trigonometric algebra. Okay, so remember that one, okay? Tangent theta is also equal to sine theta over cosine theta. Okay, besides those three, we also have the three Pythagorean identities. Really, it's only one identity, okay? And that one identity is sine squared theta plus cosine squared theta equals 1. Okay, if I go back several slides, okay, remember I had x squared plus y squared equals 1? Well, x is nothing more than cosine of theta, and y is nothing more than sine of theta. So that's where we get our Pythagorean identity here. Sine squared plus cosine squared theta equals 1. All the other two, okay, tangent squared theta plus 1 equals secant squared theta, and 1 plus cotangent squared theta equals cosecant squared theta, all derive from that first one by dividing by either cosine squared or dividing both sides by sine squared theta. Okay, so really, you really only need to memorize the first one, sine squared theta plus cosine squared theta. Okay, so here's a problem to practice. Okay, try doing this at home, and we'll talk about it in class tomorrow. Thank you.